Now, this question's a little bit weird because it says use absolute value to determine the distance. You don't really need the absolute value because you could do this based on stuff you already know. So if I give you two numbers on a number line, like 5 and 2, what's the distance between them? 3. That one you just like super easy, right? If I gave you bigger numbers, like 105 and 82, and I asked you the distance between them, what would you do?
105 minus 82.
You do 105 minus 82. Makes sense that you would subtract to find the distance in between them, right? So if I had a number line, this is really easy. You had 105 and 82. This distance in between would be 105 minus 82. Now let's say for a very strange reason, you didn't realize 105 was bigger than 82. And you accidentally did 82 minus 105. You would get the wrong answer, right? If I did 82 minus 105, I would get negative 23. What should the answer be? Positive 23. But this is where the absolute values actually come in handy because you'd be like, oh, I should have realized 105 was bigger than 82, but I did it in the wrong order. Instead of having to erase all of it, you could just go, oh, I'm going to just add absolute values as I go, which makes this 23, and I'm okay. Because sometimes it is, like, sometimes you can do it in the wrong order if the numbers are tricky looking. And usually when they get tricky looking, it's with negative numbers, as in part A. Right? When you see 8.5 and 3.7, I know there's negatives in front, but our brain sometimes goes, oh, negative. I'm not going to worry about that right now. Your brain might go, 8.5 looks bigger than 3.7. In reality, negative 3.7 is bigger than negative 8.5, but you might accidentally put them in the wrong order. And then you go and do your math, and you're like, it's equal to, uh-oh, I got negative 4.8. The distance between them should be positive 4.8. I could just go back and add absolute values. So I think that might be one of the things that they want you to sort of see with using the absolute values to figure things out. But if you had done this question, like, I think it's obvious that the 4 and 2/3 is bigger than the negative number. And you did that without the absolute values, it's perfectly fine, because you're going to get a positive number. Subtracting a negative is adding. And I just want to talk a little bit about, generally in higher level math, we don't use mixed fractions a lot. We tend to really use improper fractions. So our first little test of, do you remember how to do that? Do you remember how to change this to an improper fraction? 4 and 2/3 would be what over 3?
Multiply by the denominator.
Right, so 4 times 3 is 12, and add the 2, you get 14. Now, why does that work? Because a mixed fraction, you read it like this, right? 4 and 2/3. And in math, a symbol for and would be like adding. It's 4, and you add another 2/3. That's what a mixed fraction is. And if you were adding fractions, you would need a common denominator, and the 4 is 12 over 3. Now, it would be annoying to write that out every single time when you try to change something from a mixed fraction to an improper fraction. So we learned these ideas like, oh, you multiply 4 times the denominator, right? 4 times 3 is 12. Well, that gave us, because 4 is really 12 over 3, and then you have and 2 over 3, that's why you add that to the 2 at the top. So sometimes I like to show things like this because you might remember how to do it, but you're like, I don't know why we do that. maybe that explains a little bit of the why behind it. So this one too, like 5 times 5 is 25, plus 3, this is going to be 28 over 5. Good? And then how do you add fractions? What's the rule for adding fractions?
The denominators need to be the same.
Denominators need to be the same. So I'm going to make these both 15, which means this one multiplied by 5 here also need to multiply by 5 there, giving me 70. And this one multiplies by 3 there, which means I also multiply by 3 there. Gives me 84. And then this adds up to 154 over 15. How many 15s are 154? 10 full ones. And then how many would you have left over? 4 15s left over. Okay? Now, I said that in higher level mathematics, we tend to use improper fractions way more. But that doesn't necessarily mean that that's the easiest or the best way to do it. Okay? I probably, like mental math-wise, is like, ooh, right? How's your 14 times table? It's not quite as good as your 7 times table, I'm guessing. And your 28 times table might also be never on the list of things you worked on, right? So if I had this, if I had 4 and 2/3, and I added 5 and 3/5, if I wanted to do this easier and I thought of it like that, well, 4 plus 5 is really easy to do. That's 9. And my 2/3 is really 10/15. And my 3/5 is really 9/15. So this is like 9 and 19/15. That's over 1, right? That's like 1 and 4/15. Well, if I add that 1 to the 9, that's 10. And then I have 4/15. I like that. As far as mental math goes, like the biggest number I ran into is a 19. Not nearly as scary as that 84. Okay? But I'm going to say that usually we don't work with mixed fractions as much in higher level math. We're generally dealing with improper fractions. And if the numbers are big, well, we have a calculator to help us with some of that stuff. It's not so bad. But it's kind of nice to see, oh, but if I had no calculator, actually the thing on the right makes a lot of sense to do it that way. Okay. So, questions for this one? You can circle 5 and 8.